Hi everyone, my name is Michael Barsoom and I'm a senior here at Drexel. And today I'll be giving you guys a preview of my thesis project and what it's like to work in a lab. My research project involves using battery materials, specifically manganese oxide nanowires, to desalinate water. We are interested in these materials because they have tunnels that have shown promise in removing salts from water. This is a really important project as of the water on this planet, only 3% is fresh drinking water. And of that 3%, most of it is tied up in our ice caps. As our global temperatures rise, we really need an inexpensive solution to remove salt from water. So, I hope you guys enjoy.
Before I can desalinate anything, I need to synthesize my active materials. I begin by adding water, ammonium chloride, and potassium permanganate, which results in a really pretty purple solution, as you can see here. After mixing thoroughly, I seal it in a steel autoclave. This allows me to increase the temperature and pressure inside the vessel to recreate conditions under the Earth's crust. Now I can make materials that would not normally be possible. And here we have to seal them very, very tightly. Then I write things down because it makes me look smart, and it's not science if you don't write it down. Now I'm bringing the autoclaves to the furnace, where they'll be heated for the next 48 to 96 hours. And I always say goodbye.
Much later.
Now that all my reactants have converted, I retrieve them from the furnace. Well, first I have to try to figure out how to turn the lights on. Oh, there we go. Now I open them up, and as you can see, I have a billowy brown solid in my solution. This is manganese oxide, and although you can't see it now, these are nanowires. I'll show you what I mean under the microscope later. Now I need to separate the solids from the water and wash it thoroughly. Once all the water has passed through the filter, I receive a substance that looks like this, and then I dry it.
Many hours later.
Once dry, I will now roll my electrodes, which you guys have probably heard before when people talk about batteries. I first need to grind the manganese oxide and then mix it with a conductive additive, which is the black powder here, so that it will conduct electricity. From here, I'm going to add glue and alcohol so I can make a kind of dough. And then centrifuge it, which is just a fancy word for spin around really fast. Then, once I have it nice and rolled out, just like making cookies, I punch out my electrodes. But you don't want to eat these. Behind the scenes, I rolled some carbon electrodes with a similar process, and now it's time to desalinate. Here, I have mounted both electrodes in the cell. I add some separators, which allow the solution to flow through the cell, and then I seal it tightly so no air can get in. Now I attach the cell to a potentiostat, sorry I'm in the way, which imparts a voltage on the cell, which is how I'm able to remove salt from the solution. Then the solution is pumped through the electrodes, and I can monitor the whole process with a conductivity probe, which has yellow tape on it here. Here you can see a mixture of ions, both positively charged, red, and negatively charged, yellow. We impart a bias, and opposites attract, and our ions are removed, or our salt is removed from solution. We can then flip that bias and put all the salt back into the solution. We can monitor these changes in salt removal and release with the conductivity probe. More ions means more conductivity. We can also monitor changes in concentration with the ion chromatogram, which is shown here, by taking samples at prescribed intervals and running them through the IC column, which gives us a spectrum and gives us exact concentrations. Now that you guys are experts on how I desalinate, it's time to show you one of my favorite things about research, the scanning electron microscope, which uses electrons rather than light to image really small objects. Wait, where did you guys go? Oh my gosh, I leave you alone for 2 seconds and you end up inside the SEM? Where was I? Oh, right. SEM can look at really small samples, as shown here, and magnify them up to 3 million times. Here, I'm focusing the microscope and moving the sample around to find the exact images I want to take. Once I bring you guys a little closer, you can see the nanowires that I was talking about. In order to see that these are actually tunnels inside the nanowires, we would need a different machine, which is called a transmission electron microscope, pictured here, and we would be able to get images that look like this, which show the tunnel structures inside the wires. Thanks so much for watching. I hope you guys enjoyed and maybe learned something.